Good evening everybody. In this class we are going to find out relation between velocity, frequency and wavelength. We know that velocity is equal to displacement by time. Velocity is defined as rate of change of displacement. That means rate of change of means by time. V is equal to S by T. Normally whenever you consider any wave, we will be considering like this. The wave usually travels one crest. The wave usually travels one crest and one trough. The distance between one crest and one trough is called lambda. So displacement is measured in lambda. Hence S is given by lambda. V is equal to lambda by T. We already know that 1 by time period is nothing but frequency. So V is equal to lambda. V is equal to lambda into F. Now, V is equal to F lambda. V is equal to F lambda. Now, we are going to find out the relation between frequency and wavelength. Now, F is equal to V by lambda. That means if frequency increases, wavelength decreases. If wavelength increases, frequency decreases. The relation between frequency and wavelength are inversely proportional to each other. If frequency increases, wavelength decreases. If wavelength increases, frequency decreases. V is equal to mu lambda or V is equal to F lambda. And one more thing I would like to tell you. If frequency increases, then energy also increases. If frequency decreases, energy also decreases. The number of waves produced in a second is called frequency. Frequency is measured in hertz. Frequency is measured in hertz or frequency is measured in cycles per second. The number of waves produced in a second is nothing but frequency. And now the relation between velocity and lambda. Velocity is directly proportional to lambda. If velocity increases, wavelength also increases. If velocity decreases, then wavelength also decreases. Now I would like to tell you, whenever with the help of a wooden plank, try to make a small hole in the wooden plank. Try to place a prism on the table, so such that the wooden plank, prism and try to arrange a screen in the form of a white paper. Everything are on the straight line. If you pass a light to the wooden plank, then it falls on the prism. Then prism converts white color into splits white color into 7 colors. Then we see VGR. See, red color has more wavelength, less frequency, less velocity. Whereas violet color has less wavelength, more frequency and more velocity. Sorry, if red color has more wavelength, then its velocity is more and frequency is less. If violet color has less wavelength, its frequency is more and velocity is also less, because wavelength is directly proportional to velocity. And in this class, I am going to tell you about electromagnetic spectrum also. Now, light is a form of energy which causes a sensation of vision. Sound is a form of energy which causes a sensation of hearing. If you take light is a transverse wave, light is an electromagnetic wave, but sound is a longitudinal wave. If you take one bucket of water and if you drop a stone, you can see the ripples. I mean, you can see some waves. If any disturbance created in any medium is called a wave. Now let us consider a charge. Whenever charge vibrates, it gets energy, and there is nothing, it creates electric field. And on further vibrating, or the changes in the direction of the electric field, it creates magnetic field. And charge creates electromagnetic field. Light is an electromagnetic wave. Both electric field and magnetic field are perpendicular to each other. Let us consider the electric field. Electric field on x-axis and the magnetic field on y-axis. The diagram will be like this, because electric field and magnetic field are always perpendicular to each other. electric field and magnetic field are always perpendicular to each other. Now, coming to the point, we can see only between 400 nanometers to 700 nanometers that light is called visible light. Only we can see up to the visible light. So beyond less than 400 nanometers, that is gamma rays, we cannot see. Gamma rays has shorter wavelength, and greater than 700 nanometers we have radio waves. Radio waves also we cannot see. So if anything that lies between 400 nanometers to 700 nanometers, that is called visible light, that only we can see. And in this class we are going to study about continuous. If you are holding a pipe of water in your hand, with the help of a finger if you are holding, then you release the finger, the entire water falls on a wall. It is like an example of continuous spectrum. Or if you have some basket of balls, if you release one ball after another ball, after that another ball, these are the examples of discrete spectrum, where the students in the assembly will go. This is the example of discrete spectrum, and whenever the school bell rings, the students go out with they won't go in a proper line. Everybody wants to go first, and that is the example of continuous spectrum. Normally, if one color overlaps on another color, this is an example of impure. This is an example of impure spectrum. This Planck's work. Planck is a German scientist who got Nobel Prize. He is famous for his quantum theory, and he has proposed a theory. His theory is E is equal to h nu, where h is called Planck's constant. Its value is 6.626 into 10 power minus 34 joule into second, because h nu is equal to E, h is equal to E by nu. E is measured in joules, 1 by nu frequency is measured in seconds. In this way, we got the unit joule into second, and we are going to study in the further videos.